Hey, Sunshines. We're going to do a proof using the angle addition postulate or the angle addition property. Most of the time it's called postulate, but specifically within Alex uses the word property. I don't care which you use if you're doing classwork outside of Alex, but with Alex, obviously you're looking for the word property. Alex usually asks you for a drop-down list. You're not going to have to type out the name yourself, but you're looking for angle addition property within Alex. And so I like to start my proofs out with my given information. You could start off with your angle addition property postulate, but I like using the givens first. So I know that the measure of angle 1 equals the measure of angle 2. So it's you should always mark off anything that's congruent on your picture, on your diagram. So I know that 1 and 2 are the same size, so I'm going to mark them with one little arc each. Because I have access to colors, I'm going to use colors too because it makes it so much easier to see what you're doing, especially for a proof like this. We're going to be using substitution. When you color code things, it's a lot easier for you to find what you want to substitute. And then we can put that into our statements. It's true because it's given. So your statements are all of the things that you're talking about that have relationships to each other, and you're going to go through them slowly and link them. You're going to start with the information that you know to be true regardless of anything else, like your given information and your angle addition property. The statements that you make using that property are also standalone statements, but then you're going to start putting that information together, and then your reasons are how you justify each step. So the measure of angle 3 equals measure of angle 4. That's one of our given statements, so it's true to it's true because it's given to us. And I marked it off in my diagram. This time I used 2 little arcs. I'm color coding, so I could get away with marking 1 arc each because I'm using the colors. But it's still a good idea to use proper notation. And proper notation is that you use the number of arcs to denote which pairs go with each other. And then I can't say this. My goal is that I want to prove that the measure of angle QPS equals the measure of angle TPV. So whatever I'm proving is going to be my last statement way at the end. I can't say it yet because I don't have enough information yet to get there. But it's a good idea to just kind of indicate in your picture where you're trying to end up. So I'm going to use funny little curly cues to mark off those angles because I don't know that it's true. So I can't mark them as being congruent because I haven't shown it yet. But it's a nice way to just see what I'm talking about because it's a lot easier to see the relationships between these angles. Once you color code them, this looks exactly like this because it's made up of the same types of pieces. It's made up of a pink piece plus a green piece equals the blue pieces that I want. So it's a little easier to see that my goal here is to just trade out statements so that I can say, well, if one pink one plus one green one equals a blue one, then the other pink one plus the other green one is going to equal the blue one. And so that means the other blue one's going to be the same thing. So now we need to make those pink one plus green one equals a blue one statements. So I'm going to start with just one side. So this statement, this is what the angle addition postulate or property does. It says that a little piece plus a little piece equals the measure of the whole angle. So physically, this blue angle is made up of the pink angle and the green angle. So that means if I add the measure of the pink one plus the measure of the green one, I'm going to get the measure of the blue one. It's kind of common sense. You know this as children growing up, that if you take two pieces and put them back together, as soon as you learn about measurements, you learn that like your first word problems are measuring things out. You usually do it with more like segments instead of with angles. But if you measure out that something is 1 inch and 2 inches, then you know that together that's going to be a 3-inch stick. And the same is true for angles, even though you're a little older when you start to learn about degrees. So the other one I know is made up of the same color pieces. You could make your other angle addition postulate statement now and say angle addition postulate. Because we're trading things out, I think it's a little easier if we maybe start with just here and start trading out the pieces and then go back. So for statement 4, I took statement 3 and I copied it down, except I replaced. I know that angle 1 and angle 2 are the same size. They're the same thing mathematically. So I can swap them out using substitution. Substitution is the property that says if two things are the same size, the same value, you can replace one with the other. It's the same reason if we know that x is 2, we can then plug 2 in for x into our equation. So this is a little note here that I made just to keep track of what I'm doing. You don't have to do this in your own proofs. This is just something that I like to do as a teacher to help kind of explain where I'm going, but it also helps me keep track. If I look at my notes a year later and I'm trying to remember and I don't feel like redoing a proof, I can look through and be like, why did I substitute? Oh, right. I took statement 1 and I plugged it into statement 3. Okay, that makes sense. So it's useful, but this isn't a standard practice. It's not required of you. But I took statement 1 and I plugged it into statement 3. So statement 3 is what I used, but I just replaced using the equality from statement 1. Now for statement 5, I just copied down statement 4, but I replaced angle 3 with angle 4. The green angles I swapped out. You can go all the way from 3 to 5 and just do a double replace, like just replace angle 2, or sorry, replace angle 1 and angle 3 at the same time. It's just a little easier for me to show you what I'm doing if I do it one step at a time. So now I have angle 2 and angle 4 add up to equal the measure of angle QPS, but 2 and 4 are the actual pieces of angle TPV. So now it would really help to have the statement using 2 and 4 and linking them to the other angle, and then I can bring that other angle into my proof. Because right now, I don't even have angle TPV in here, so I'm not really going to get very far proving something about angle TPV if I never talk about it. And so this statement, measure of angle 2 plus the measure of angle 4 equals the measure of angle TPV. I could have made this statement way up here at the beginning, and it would be valid. It doesn't matter where you put it, as long as you put it before the statement we're about to make. And as long as you write the angle that you mean to write. So now I have angle t plus measure of angle t plus measure of angle 4 in two different statements. So it equals measure of angle QPS and it equals the measure of angle TPV. So I can just swap this out and I'm going to replace this one with this because this equals this. When you make this statement, you could make it either way. You could substitute the other way and put TPV up here. But we need, as a formal proof, we need to make exactly this statement. If you write measure of angle TPV equals measure of angle QPS as your next statement, Alex isn't going to accept that as completing your proof. I'm not going to accept that as completing your proof. It's not the same thing formally. It means the same thing, and it just takes one more step. If you write it backwards, you just have to use the symmetric property to flip the statement around as an extra statement. But it's easier if you just write it the correct way in the first place. Also, as a side note, make sure that you don't mix up your angle names. Even though you know that angle QPS and angle SPQ are the same angle, you want to make sure that you're using the same name that's used throughout the proof, throughout your given and prove information, because you want to make sure that your proofs, that your final statement matches the thing you're supposed to prove exactly. And it does. So now we can say QED which stands for Quod erat demonstrandum, which is Latin for what was to be shown. So what it means is I was supposed to show this and I showed you this, so I'm done. So there's, old fashioned Latin sass. um, in modern times, you still see most people will write QED for formal proofs, but now you'll see people do other silly things. A lot of times you'll see like a little box or something that just shows, okay, that's the end. I had a professor in college who wrote MEP, which stood for Muerto es Pollo. So uh, when you're doing proofs in Alex, you just need to, click verify and it'll tell you you're done so you can click check and turn your problem in. When you do it on paper, I don't care if you actually write any kind of finishing thing, but you're welcome to do that. That's the fancy formal thing to do.